Hello everyone. My name is Seung, Nanyang Technological University, Singapore. I'm very honored to present this research, the title, Digital Twins and Surrogate Modeling Techniques. Before the presentation, I'd like to introduce myself. Currently, I'm Associate Professor, School of Mechanical and Aerospace Engineering, Nanyang Technological University, Singapore. My research more focused on how to apply science and economic theory to design of the customized sustainable product service system. I'm utilizing a lot of the design theory method, also data science approach, especially the modeling and simulation. Also, I am research focused on design for additive manufacturing, 3D printing, and smart factory and digital twin. Today's presentation, I'd like to introduce the background of the digital twins, and I will give some detail of what is the digital twin, what kind of applications and benefit. Also, surrogate model is very important in modeling in digital twin. Then I will finish the closing remark and future work. What is Industry 4.0? Everybody very familiar with these terminologies. Basically, Industry 4.0, we can consider digital industry. Industry 4.0 is one of the projects developed by German government. Basically, digital industry is based on customizable product development. We utilizing a flexible manufacturing environment. Before the presentation, I will give some very short video developed by HMGICS. Previous video provided one of the example how to utilizing digital twin. In future, customer definitely want to more smart and individualized products. So definitely the company, they have this kind of capability to support this the customer need. For example, reduce time to market significantly, more enhancing flexibility in manufacturing system, increasing quality of products, overall operation efficiency, definitely increasing securities. For this one, most company are utilizing digital twin. This one is more provided to reducing asset downtime, optimizing process time, as you mentioned before, reduced time to market. Therefore, digital twin technology are very attractive to a lot of different industry. This figure provides some example pre and post COVID-19 scenario in digital twin market. Definitely, after COVID-19 pandemic, we are looking for digital twin technologies. Here is some application in different industry. General Electronics developing engine for aircraft. They're utilizing digital twin and digital manufacturing for developing smart factory. Siemens is one of the software company provide the relevant technology in digital twin. They utilizing digital twin 3 different phases, like a digital twin products, production, and performance. One of them is BMW automotive industry. They also utilizing the digital twin concept in production system. Another example, Mercedes-Benz is utilizing digital twin to more maximize the flexibility in the production line. Finally, they developing new digital infrastructure utilizing the 5G network as well. Digital twin technology applied to smart city is our lifestyle. One of the report is by 2025, some 500 cities in all over the world utilizing this digital twin concept. Also, in UK, the government in 2018 established the National Digital Twin Program to developing kind of a national digital twins. In digital twin, we definitely utilizing a lot of different technology. So we also involving engineering modeling, digitalization, company as well. Singapore also looking for digital twin, developing the smart city. So far, we discussed about one of the application of digital twin. So digital twin can play a key role in combining related to physical and virtual entity into more efficient cyber-physical production system as well. To implement the digital twin, digitalization, interoperability, and cooperative network should be achieved in progress towards smart factory and city. So digital twin, we need three components. One of them is a physical objective and virtual models. Also, network connection between physical and virtual model. Here is a application, especially manufacturing area. One of them is design, the design optimization, the quality management, supply chain, predict maintenance, so collaborations. Also, analyze the customer experience. This application is very important to developing more customized, smart, individual products. So this is the requirement definitely our future customer need. So what kind of benefit is from digital twin? As you can see, digital twin is provide the cyber physics systems. So we can provide more real-time monitoring control can be extended to a lot of the systems. Also, we increasing efficiency, also safety as well. Safety is more important to our employer and operator in our smart factory environment. Also, a predictive maintenance schedule supported by early fault detections. As you can see, all the smart factory, for example, that works by the sensor. So we can easy to understand what kind of problem particular machines. Also, this one is scenarios risk assessment as well, efficiency and well-informed decision making we can provide it. This is one of the real-time decision making we have. So we can order a lot of different benefits utilizing digital twin as well as the smart city. In digital twin application, there are difficulty and challenge of the modeling the complex and layered systems. To overcome this issue, surrogate modeling is one of the techniques to support the design space characterization, prediction, and optimization. Surrogate models are significantly simpler than simulation model and actual process, but yet possessing sufficient fidelity to predict the response. So we can easily extract from complex simulations of digital twins, also handle uncertainty and complex behavior of systems, and easily utilize in optimization control algorithm through surrogate modeling process. Surrogate model is we developing the statistic model to accurately approximate simulation output. Trained statistical model can be deployed to replace the original computer system in performing sensitivity analysis, optimization, or risk analysis. So here is a figure represented to how to compare two the simulation and the surrogate model. Basically, this design parameter can be utilizing real data simulation. We can predict, for example. However, surrogate model, we can utilize the original design data, also train the data from simulation, consolidate, then we can predict some output. Basically, surrogate model is cheaper than existing real data and simulation approach. Special case of supervised learning applied in this field, engineering design, we apply especially developing surrogate models. This table provides what kind of problem type can be applied surrogate model. A different problem, we apply different surrogate model. For example, direct and global optimization, we can apply the neural networks or the gaussian. This is a Gaussian process model, support pattern machines. Also, multi-objective optimization, also scheduling planning, we apply a lot of different surrogate model. If we are interested in this more detail, please take a look at these papers. As you can see previous slide, there are many different types of the surrogate model. So depends on the problem, what kind of model can be adapted to a particular problem. Here is a process of the building surrogate model. First of all, we design of the experiment, the gathering more data for sampling for surrogate model. Then we can simulations using detailed model. Here we can select the model and fitting the model parameter based on simulation result using detailed model. Then we can select the final model. Sometimes we can adapt sampling is improve, refine this model. Then finally we validation this model. To developing surrogate model, we need to obtain the data. So there are many different sampling methods. One of them is a spatially sampling method, another one adaptive sampling method. So here is some relevant model type can be applied to which sampling method. For example, we utilizing Latin hypercubic sampling approach for developing surrogate model. Latin hypercubic sampling is a statistical method for generating a near random sample of the parameter value from multidimensional distributions. Latin hypercubic sampling is a spacing filling based experimental design approach. Compared to traditional design of experiment, this Latin hypercubic sampling approaches could maximize the uniformity in design spaces with a small data set. Therefore, we can adapt to developing surrogate model. Here is a different type of the surrogate model. As you mentioned before, one of them linear regression, polynomials, Gaussian modeling process, or Krigings. Also, nonlinear regression model of the machine learning we can apply to developing surrogate model. Radius-based function, artificial neural networks of the meta machines can be used for developing surrogate model. One of the surrogate models is a Gaussian process regressions. Gaussian process regression is a flexible non-parametric model based on a Bayesian approach. So we can consider uncertainty in modeling process. Compared to support vector machine, artificial neural network is more suitable for small data set modeling. Also, Gaussian process regression provide the prediction uncertainty in terms of the variation. So this is very important for decision making, also optimization. Here is some example how to provide a certainty of the Gaussian process regression model. We provide the empirical data set prior, also the posterior distribution can be considered uncertainty in the process. After establish the surrogate model, one of the important processes of validation and maintenance. To validate the proposed model, we utilizing absolute error or relative mean error, root mean square error can be utilizing a validation process. In developing surrogate model, we have limitation and challenges. For example, very difficult to decide the best cutoff value, especially R square. How much is the value is the best adapt to particular problem. Also, this model may not be equal good for all data point. Another reason is the bias in data. The bias is reflected to model predictions. Also, poor generation of unknown problem can be affected to the accuracy of the surrogate model. So far, we discussed about how to develop surrogate model. For the case study, I give you some example how to develop surrogate model, especially predict production performance using input parameter from production planning. This case study, we apply to developing digital twin in smart manufacturing systems. We are utilizing 3 categories of parameter, especially the current production system load, machine-based and production-based parameters. For the surrogate model, we select the multivariate adaptive regression splints. This research is based on from this paper. Please let me know if you're more interested in details of this research. This figure provides to how to implement the digital twin in smart factory. More the digital production system provide more detailed modeling and particular machine learning process. Also, the physical platform provide more real data like the real sensor or particular robot embedded computer. All the data into the database, then how to be utilizing this data for develop the algorithm for implement digital twin. This figure provide to more detailed information data flow in digital twin, especially the decision support system in database. In decision support system, especially we apply to developing a surrogate model. As you mentioned before, we utilizing productions data, also particular machine and the performance data for predict production performance. To develop the surrogate model, we needed to training the model. For training phases, we consolidate the data from the full evaluation of the production plan and schedule. There are 2 different systems. One of them, digital production system, physical production system. Physical production system is a current state of the WIP order. For example, the current production system load. For the digital production system, we need to the machine-based, production-based parameter. For this one, we utilizing input parameter from production plan and production schedulings. After we train the data set, we start to the surrogate model generation. We apply to particular regression the model, then we finish the model generations. Next, to developing the surrogate model, I will discuss what kind of variable used for particular these problems. Especially the input, the predicted variable for current production system load, we use the average number of the whips route, also average mean routing step. In terms of machine-based parameter, we use dispatching rule, minimum, maximum batch sizes, and maximum waiting time to achieve maximum minimum batch sizes. In terms of product-based parameter, we use the mean inter-arrive time, mean demand, lot sizes. In this research, we utilizing historical data. Also, we use the simulation. We obtain the predict the performance data. For this research, we utilizing technometrics. It's a Siemens flat simulations. For the output variable, we use the performance measures. To predict performance measure, we utilize three of the matrix. One of them, the floor time. This one is represented to time the production order remains within the production system during production and queuing stages. The tardiness is a latest of the production order. Machine utilization is a proportion of the time the machine is being loaded or in processing in stages. So today's presentation, I just briefly how to developing surrogate model, particular case study. Only focused on what kind of we input floor output data. So more detailed information, please let me know or referring to these conference papers. Today's presentation, we discuss what is a digital twin, especially under in the 4.0. To developing provide more customized, personalized product, utilizing more flexible manufacturing environment. Also, we discussed the application in smart factory, different industry, also smart city. And then we discussed the surrogate model, how to develop this surrogate model based on step by step. Also, we discussed what kind of types surrogate model in particular problems. Also, we learn through the case study how to be developed surrogate model. Especially, we focused on the production system, how to we predict product performance, so what kind of input, also how to utilizing existing data, also the simulation data as well. I'd like to thank you for supporting this. The research is from a lot of different industry and government and NTU. Thank you for listening. If you have any question, feel free contact me. Here is my email address. Thank you.